keep or make the one value inside, which means you might need to simplify first, inside positive. So this is negative, so I need to make it a positive. And when I do that, I drop the absolute value symbols. So this part that I've highlighted in green is all done. I've done the absolute value of -5. However, I do need to drop down this negative sign out in front, and I need to drop down the +7. So the -5 turned positive, but then outside there was a negative sign, which still affects that new +5. So -5 plus 7 is 2. Next example, simplify 2 times. That's a multiplication symbol right there, since I have a number right next to an absolute value sign. Just like when you have a number right next to parentheses with no operation, it means multiplication. So 2 times the absolute value of -9 plus 1. What's inside the absolute value sign is just one number. If there were more than one number, I would need to simplify and evaluate the numbers inside the absolute value sign. But now I can just go ahead and do the absolute value of -9, which is +9. So I have 2, I have 2 times 9 plus 1. Make sure we multiply before we add, because in order of operations, multiplication and division comes before addition and subtraction. So we have 18 plus 1, which is 19. Bada bing, bada boom. Adding matrices. When you add 2 matrices, they need to be the exact same size. So these are both 2 by 2. And your answer will be 2 by 2. So to get the top left entry, I take 5 plus 1, and I get 6. To get the top right entry, I take corresponding values. I take corresponding entry levels or places. So top right plus top right is +1. To get the bottom left, I take -2 plus -3, which is -5. To get the bottom right, I take 1 plus -4, which is -3. Awesome. Now, to subtract matrices. Personally, I'm not a fan of subtracting. I like to add the opposite. So I'm going to change the subtraction sign to adding, but then I'm going to do the opposite of every single entry in the second matrix. You can, teachers in the past have used the phrase keep, switch, flip. You keep this first value the same, you switch this to a plus sign, but then you flip the sign of the second matrix. So change this to addition, flip all of these symbols to the opposite. So a positive goes to a negative, positive goes to a negative, negative goes to a positive, negative goes to a positive, negative goes to a positive, positive goes to a negative. Now, if I relook at this problem, I have this first matrix plus the second matrix. So now it's the exact same process as what we were doing. To get the top left entry, take -3 plus -2, you get -5. Top right entry, 0 plus +4 is 4. Middle left entry, -6 plus -1 is -7. 4 plus +3 is 7. 1 plus 1 is 2. -4 plus -9 is -13. I guess I forgot to put some circles on there. Oops. All right. That's the first side, I believe, for you. Second side. Oh, there's problems below it, I believe. All right, so below that, in a deck of cards, in the deck of 52 cards, the standard deck, 26 cards are red. If you choose randomly, what is the probability of selecting a red card from the deck? Probability means the favorable outcome, whatever they're asking about. In this case, they're asking about red. So in this case, it's red, divided by the total number of outcomes. So in this case, it's 52 cards because or it's the total deck. Let's just say it that way. It's the deck, the whole deck. Whole deck. So now let's put values with that. How many reds are there? There's 26 reds. How many total cards are there, including reds? There's 52. So that simplifies to 1/2. The probability of getting a red card on a random draw out of a full deck of cards is 1/2. What are the odds of selecting a red from a deck? Now, odds means favorable. Now, in this case, they're asking about reds. So red is favorable, divided by unfavorable. So all the other different cards, that's not, there we go. All the other different cards that are not reds, unfavorable. So in a deck of cards, it's either the cards are red or they are black. If we're looking at just the colors of the cards, we don't care what numbers or they are, or the suit or anything like that. So the only type of card that's unfavorable in a deck of cards, if we win the game or if we want a red, is the black cards. So in a 52 deck of cards, there are 26 red cards and there are 26 black cards. So our solution is 1-to-1. When we use probabilities, we usually use the phrase some number to some number. In horse racing or I don't know, even football, I think they do some odds. You'd say it's 1-to-1 odds or 5-to-20 odds or something like that. I don't bet on horse racing or football. So, but anyway, we use the word to, this to that. Looks like you're gonna do some guppies and goldfish here in a second. On the back, we're doing some distributing. So we multiply, this is multiplication. So we have -3 times 2x, which is -6x. And then careful on this last one, we have -3 times a -5. If it helps to add the opposite, do it. So I have a -3 times a -5, that's a +15. So we bring a plus sign down in front of it. Same thing here with distribution. I have 2x times 4x. I could rewrite that as 2x, I could write it out as 2x times 4x minus 2x times 3. Now multiplication we can rearrange. So in red here, really I could write this as 2 times 4 times x. And in blue I could write this as 2 times 3 times x. Over back in red, 2 times 4 is 8. X times x means x squared. In blue, subtracting off 2 times 3 is 6, and the x tags along. Here we have distribution, but the distribution ends at the parentheses. So this is my distribution portion. So I have 2x times 3x and 2x times 4. So 2x times 3x plus 2x times 4. I'm done distributing now, but I do have this -5 at the end. -5x, excuse me. So to simplify 2x times 3x, we get, well, so if I rearrange this, I could rewrite this as 2 times 3. That gives me 6, and then x times x is x squared. In red, I have 2 times 4 times x. You don't need to necessarily rewrite it, but really I have 2 times 4, which is 8, and the x tags along. And then I have this -5x hanging out. So I've done the multiplying. Now I need to combine any like terms that I can. And the only like terms I can combine here is 8x and -5x. They have the exact same ending. Like terms have the same variable, the same letter, and the same exponent. So there are no other x squared, so I can't combine anything else with this 6x squared, which is sad, but it's easier to write. Like I don't need to do any math with that. I just write down 6x squared, and I'm done with that term. But then I do need to combine these like terms. 8x minus 5x is 3x. Last but not least, we have a little fraction operation. When we multiply fractions, that's the easiest of all, when we just multiply straight across. So straight across the top, I have -8, and across the bottom, I have 30. Always, with any fraction, always try to simplify. What's the biggest number, the greatest common factor of 8 and 30? I think it's just 2. So I get -4 on top and 15 on the bottom. Sometimes we try to grab the greatest common factor, but we don't. So then always look at your final answer and make sure you can't simplify it anymore. Make sure there's not another number that divides into the top and the bottom evenly. When we divide fractions, we can use the old phrase keep, switch, flip again. We're going to keep this first fraction as it is, -4/5. We're going to switch the division to multiplication, and we're going to flip or take the reciprocal of, so flipping is the reciprocal of the second fraction. So there's a phrase that dividing fractions is also the same as multiplying by the reciprocal of the second. So now this is just like example number 10. I am multiplying fractions, so I multiply straight across the top. On top, -4 times 6 is -24. On the bottom, 5 times 2 is 10. But always try to simplify that. So I can divide the top and the bottom by 2, because 2 goes into 24 and 10. So the best answer is -12/5. And there's no other number that divides into -12 and 5 evenly. So that's the answer that will show up on a multiple choice test. That's what you need to look for. This probably won't show up at all. So you got to know that I got to take it one step further and simplify. Last one, example 12. To add or subtract fractions. So if we're adding fracts or subtracting fractions, we need a common denominator. One way to do that is to take your denominators and multiply them together. So you could take 4 times 6 and get 24. So 24 could be a common denominator. It is a common denominator, but I like to get the smallest common denominator. It makes the rest of the math smaller and easier, and it reduces the amount of simplifying I have to do at the end for my fraction answer. So 4 goes into, let's list the multiples of 4. 4, 8, 12, 16, 20, 24. Sure enough, there's that 24. Let's list the multiples of 6. 6, 12, 4 and 6 both go into 12. So 12 is also a common denominator. 12 is the least common multiple, the least common number that goes into the multiples of 4 and 6. When you find your common denominator, whether you're going to use 12 or 24, write 3 fractions with 12 as the denominator. This first fraction is whatever is equivalent to -3/4. So this 4 becomes a 12. Well, 4 times what is 12? 4 times 1, 2, 3. So we have to multiply the bottom by 3. But to keep these fractions equivalent, what you do to the bottom, you have to do to the top. So I get -9. What this means is -3/4 is the same as -9/12. They're equivalent. I'm not changing the value. I'm just making it more pie pieces, but the same amount of actual pie, just cutting the pieces smaller. -2/6. Well, 6 times what is 12? 6 times 2. So I'm going to multiply the bottom by 2 to get 12, but what I do to the bottom, I have to do to the top. So 2/6 is the same as 4/12. Ooh, folks, there is a mistake right now as you look at this.